We are constantly being told that AI is changing everything, right? But there's this huge, multi-trillion-dollar puzzle right at the center of it all. If AI is so revolutionary, then where's that massive productivity boom we were promised? Today, we're going to unpack that exact question.
Okay, let's just dive right in. We hear it all the time. AI is transforming the world. But, when you actually look at the broad economic numbers, that huge impact, it's just not obvious yet. It kind of feels like we're all standing on the beach, waiting for this giant tidal wave that we know is coming, but it's still way out at sea.
So to really get our heads around this puzzle, we need a framework. And luckily, economists have one. They call it the productivity J-curve. And the big idea is this. With any truly game-changing technology, things often get a little bit worse before they get a whole lot better. You have this initial phase of cost and disruption, and only then does the real payoff start to kick in.
And right now, well, we are deep in the dip of that J-curve. This whole phase is defined by one single, overwhelming thing, a truly staggering bet on the future. And it's being measured in hundreds and hundreds of billions of dollars.
I mean, just look at this number. In 2024 alone, the tech giants who are laying the actual groundwork for AI, we're talking Microsoft, Google, Amazon, they are spending a collective $200 billion. And that's on physical stuff, servers, data centers, the real-world hardware you need to make this revolution happen. It's literally the cost of building the future.
And here's the crazy part. It's accelerating at a breathtaking pace. That number is projected to leap to over $400 billion next year. That's not just growth. It's a full-blown infrastructure arms race. All of this spending, all this money is pouring into what we can call the very first layer of the AI economy, the infrastructure layer. Think of it as the physical foundation. We're talking about the chips, the servers, and these absolutely colossal data centers. It's the digital version of building all the roads, all the bridges, and all the power plants for an entirely new city.
Now, this is where it gets really fascinating. Inside this first layer, you basically have two different kinds of companies playing two very different games. On one side, you have the tool makers, the ones selling the shovels, like NVIDIA. They design and sell the essential chips. And on the other side, you have the builders, the big cloud providers who are buying up all those shovels to actually construct this massive infrastructure. And financially, their stories could not be more different.
And this table just lays it all out perfectly. NVIDIA is unbelievably profitable. They're making about 75 cents on every single dollar of chips they sell. For every dollar they invest in their business, they get almost $1 back in profit every year. It's incredible. But then you look at the builders who are buying those chips. They're the ones taking on all the cost, all the risk, and it's putting this immense pressure on them to, eventually make all this incredibly expensive infrastructure pay off.
Okay, so let's move up to the next layer and see what all that expensive hardware is actually being built for. We're moving from the physical foundation up to the intelligence itself.
And this is that intelligence layer. This is where companies like OpenAI and Anthropic take all that massive computing power and use it to train the large language models that actually power the AI applications we all interact with. This is where the digital brains are created.
And the potential for making money here is just enormous. You can see it so clearly in OpenAI's growth. They more than doubled their revenue in less than a year. It just goes to show you the incredible demand there is for access to these powerful models.
But, building these AI brains, it's not a guaranteed path to riches. This layer is facing some really serious challenges. For one thing, what happens if open source models make these super expensive brains basically a cheap commodity? Then there's the trust issue. Nearly 8 out of 10 leaders are worried about AI just making stuff up. And maybe biggest of all, there's a huge legal storm brewing over whether it was even legal to use all that copyrighted data for training in the first place.
So, that brings us to the crucial point. How does this massive investment in infrastructure and intelligence finally turn into real-world value? How does it create productivity? Well, this is where we start climbing up the other side of that J-curve.
And that happens here in the application layer. This is where all that complex technology finally gets embedded into the software and tools that people use every single day to do their jobs. Everything from writing code to helping customers. This is where the rubber meets the road.
And the data we're seeing here is just incredibly compelling. On a task-by-task basis, AI is already delivering in a big way. Software developers using GitHub Copilot, they're finishing tasks 55% faster. Support agents, they're resolving 14% more issues every single hour. When knowledge workers use these tools, they're a third more productive. The gains at the individual level are absolutely real, and they are significant.
Which, of course, brings us right back to our original question. If the tools are working so well for individual tasks, if they're making people so much more efficient, why aren't we seeing that explosive growth across the entire economy? What's the holdup?
So here's the answer. It's called the productivity paradox. And the punchline is this: the problem isn't the technology. The bottlenecks, they're human. Think about it. It's incredibly expensive and disruptive to completely change the way an entire company works. There's a huge talent gap. Companies just aren't training their people how to use these tools effectively. And even though almost every company is trying AI, most of them are just running little experiments, not truly integrating it across their entire business.
So the real takeaway here is that we are still in that messy, expensive, disruptive part of the J-curve. The investment is real, the disruption is real, but that huge economic payoff, that's still on the horizon. Because taking all those little individual productivity wins and scaling them across an entire company, let alone an entire economy, that's the really hard, really complex challenge that we still have to solve.
The technology's potential is crystal clear. The data from the front lines proves that these tools can make us faster, smarter, and more effective. But to realize that potential on a grand scale, that requires a fundamental change not just in our tools, but in how we structure our companies, how we train our people, and ultimately how we all think about work. That's the real puzzle we need to solve.